There is a volcano in Alaska that has not had a confirmed eruption in roughly 570,000 years. It sits so far from anyone that the nearest working seismometer is 17 miles away. And for the past 5 months, it has been doing something scientists did not expect to see there in their lifetimes. In the next few minutes, I will walk you through exactly what has been detected beneath this mountain, why 2 completely independent instruments had to agree before anyone took it seriously, why the entire Alaskan landscape is built to produce mountains like this one, and what actually happens if the thing underneath it keeps rising. The volcano is called Mount Kuprianoff. It sits on the Alaska Peninsula, part of a chain of 5 volcanic centers facing Stepovac Bay, roughly 500 miles southwest of Anchorage. It is heavily glaciated, 6,217 feet tall, and by every account, it is one of the quietest volcanoes in the entire state. There is no confirmed historical eruption on record for this mountain. Not one. The only candidate is a single, disputed report from a pilot in 1987 who thought he saw a small ash and steam emission. That is the entire eruptive record of Mount Kupreanof. Before we get into what's happening underneath it right now, you need to understand why Alaska has a mountain like this at all, because the answer explains almost everything else in this story. Alaska sits on top of one of the most active plate boundaries on Earth. The Pacific Plate is diving underneath the North American Plate, along a scar in the ocean floor called the Aleutian Trench, sliding downward at a shallow angle, deep into the mantle. As that slab of ocean floor descends, it heats up and water trapped inside the rock is squeezed out. That water lowers the melting point of the rock above it, generating pockets of magma that slowly rise toward the surface. That single mechanism, one plate sliding beneath another, is the reason Alaska hosts more than 50 historically active volcanoes strung out along the Aleutian Islands and the Alaska Peninsula like beads on a wire. It is part of the Pacific Ring of Fire, the same subduction system responsible for the volcanoes of Japan, Indonesia, and the Andes. Mount Kupreanof is simply one bead on that wire that has, until now, stayed unusually silent. This same stretch of the Alaska Peninsula has produced eruptions on a scale most people never associate with the United States at all. In June of 1912, a volcano called Novarupta, less than 200 miles from Kuprianof, produced the largest volcanic eruption anywhere on Earth in the entire 20th century, ejecting roughly 3 cubic miles of magma in about 60 hours and burying a nearby valley under ash hundreds of feet deep. Ash from that eruption fell as far away as Africa. This is not a quiet backwater of the volcanic world. It is one of the most explosively productive stretches of crust on the planet, and Kuprianof sits right in the middle of it. And then, in February of 2026, the ground underneath it started shaking in a pattern the Alaska Volcano Observatory takes very seriously. The first signals were not even shallow. They were deep, low-frequency earthquakes more than 12 miles down, arriving in pulses in early February and again in early March. On their own, deep, low-frequency quakes are ambiguous. They can mean many things, but by April, the pattern climbed toward the surface. Shallow earthquakes began increasing in early April, some passing magnitude 3. And 4 days into that month, satellites picked up something Mount Kupreanof had never shown before in the observational record. Sulfur dioxide gas, emitted at a rate of 100 to 1,000 tons a day. For comparison, the background rate for this mountain is under 100 tons a day. Helicopter surveys in 2019 and 2022 had measured levels far below that. This was new. Before we get to what happened on May 12th, it helps to understand the scale the observatory uses. It runs on 4 levels: green, quiet background activity; yellow, signs of unrest above background; orange, heightened unrest with real eruption potential; red, a major eruption imminent, underway, or already producing ashfall. Moving up a rung is never taken lightly. On May 12th, the Alaska Volcano Observatory made it official. They raised Mount Kupreanof to yellow advisory, the second tier on a 4-level scale, and named the likely cause directly: a magmatic intrusion beneath the volcano. In plain terms, new molten rock was pushing up from depth into the volcano's plumbing. Here is how the lead scientist on the case, Matt Haney of the USGS, put it to reporters that week. It's a typical Alaska volcano. It's not dormant by any means. To understand why scientists needed multiple signals before making that call, you have to understand what each one actually measures, because none of them alone proves anything. Earthquakes at a volcano are not all the same, and the type matters as much as the count. Some are ordinary tectonic quakes, rock breaking under stress with no magma involved at all. Others, called volcano-tectonic earthquakes, happen when rising magma physically cracks the surrounding rock as it forces a path upward. Deeper, low-frequency events, the kind first detected at Kuprianoff in February, are usually the signature of fluid and gas moving through narrow channels far below, more like the rumble of liquid pushing through a pipe than rock snapping apart. The progression scientists watched here: deep, low-frequency signals first, then shallower, more classic quakes later, is close to a textbook description of magma working its way toward the surface. Sulfur dioxide is a gas that is dissolved in magma under pressure, the same way carbon dioxide is dissolved in a sealed soda bottle. As magma rises and the pressure around it drops, the gas comes out of solution and escapes upward, often well before any lava does. Detecting a sudden new source of that gas, one a mountain has never produced before, is one of the clearest fingerprints of fresh magma nearing the surface. It is also one of the easiest signals to fake yourself out with, because gas alone can come from an already active hydrothermal system with no fresh magma involved at all. That is exactly why scientists needed a third, independent line of evidence before calling this an intrusion with confidence. That third signal was the ground itself moving. In June, once the winter snowpack finally melted enough to get a clean signal, satellites carrying interferometric radar, InSAR for short, compared the shape of the ground around Kuprianoff to an image from the previous September. The technique works by bouncing radar off the Earth's surface from orbit and measuring, down to fractions of an inch, whether the ground has moved between two passes. The comparison showed uplift. The volcano's surface had physically risen over the preceding 8 months, and the source of that inflation traced back to a depth of roughly 3.7 miles. That is the moment the case became, in the observatory's own words, high confidence. Not one instrument reading something ambiguous, but 3 separate techniques, seismic, gas, and satellite deformation, all pointing to the same shallow depth beneath the same mountain. As Haney told reporters, "When we have 2 of our data streams, that's really making the diagnosis with higher confidence that there has been a magma intrusion." The unrest has not slowed down since. On June 15th and 16th, Kuprianoff produced its 2 largest earthquakes of the entire sequence, magnitude 3.2 and 3.6. By late June, more than 30 earthquakes of magnitude 1 or greater had been logged since the alert level first went up in May, and the volcano kept degassing. Sulfur dioxide was detected again on June 27th and the 29th, with 2 more small earthquakes, magnitude 2 and 2.3 on the 27th. As of the most recent update, July 3rd, the volcano remains at yellow advisory. Nothing has escalated further. Nothing has gone quiet either. Here is the part that makes monitoring this specific mountain unusually difficult. Mount Kuprianoff has no dedicated local monitoring network. No seismometers sit on its slopes. The nearest functioning seismic station is 17 miles away at a neighboring volcano called Veniaminoff. That means smaller earthquakes, anything under about magnitude 2, often go undetected entirely, and the ones that are picked up carry real uncertainty in their exact location. Scientists are watching one of the most active magmatic systems in Alaska right now through a narrow, imperfect window, stitched together from a distant seismometer, passing satellites, and the occasional pilot or fisherman who happens to look up. The Alaska Volcano Observatory is responsible for more than 50 active volcanoes spread across a state 1/5 the size of the entire continental United States, and only a fraction of them have anything close to real-time ground instrumentation. Kuprianoff, until this year, was never considered a priority. So what would an eruption here actually look like? The observatory's own hazard assessment is specific. Because the volcano is heavily glaciated and sits in steep, uninhabited terrain, an eruption would likely produce lahars, fast-moving slurries of volcanic debris, meltwater and ice, and pyroclastic flows down its flanks into valleys where, fortunately, no one lives. The nearest permanently inhabited place, a small community called Perryville, sits roughly 26 miles away, home to a few dozen residents, most of them Alutiiq. Even at that distance, a significant eruption could bring ashfall to the community. Fine volcanic glass and rock dust that contaminates drinking water, damages engines and machinery, and if inhaled in large enough quantities, irritates the lungs badly enough to send people with asthma or other respiratory conditions to the hospital. None of that rises to the level of the 1912 Novarupta eruption or anything close to it, but it is the realistic worst case for the people who live closest to this mountain. The greater danger for far more people isn't on the ground, it's in the sky. Mount Kuprianoff sits directly beneath some of the busiest trans-Pacific flight corridors in the world, the same routes that connect North America to Asia. A large enough ash column doesn't need to threaten a single house to become a serious problem. It only needs to drift into the path of a jet engine. This is not a hypothetical risk invented for this video. It has already happened, twice, on opposite sides of the planet, and both times it came within minutes of becoming a catastrophe. In December of 1989, KLM Flight 867, a Boeing 747 carrying more than 230 people, flew into the ash cloud from an eruption of Mount Redoubt, roughly 200 miles from Kuprianoff. Volcanic ash is not like smoke. It is powdered rock and glass, and inside a jet engine running at full temperature, that glass melts. The aircraft's engines ingested the ash, the molten glass coated the internal turbine blades, and all four engines flamed out at once. The plane fell more than 2 miles from 39,000 feet down toward 8,000 before the crew managed to restart the engines and land safely in Anchorage. Every single person on board survived. But the incident became the reason the aviation industry now treats volcanic ash with the same seriousness as a mechanical failure in progress, not a weather inconvenience. It was not even the first time it had happened. 7 years earlier, in June of 1982, British Airways Flight 9 flew through the ash cloud of Mount Galunggung in Indonesia at night, with the crew initially unable to see what was hitting the windshield. All four engines failed within minutes of each other. The plane glided engineless for what the crew later described as the longest 17 minutes of their lives, dropping from 37,000 feet before the flight crew managed to restart 3 of the 4 engines and land in Jakarta. Nobody died on that flight either. Both incidents ended the same way. Not because the danger wasn't real, but because the crews got lucky enough and skilled enough to recover before the ground did the job the volcano started. That is the real stake behind a mountain most people have never heard of. Not a village being buried, a flight path being closed, or worse, a plane not being warned in time. Now here's the part that keeps this story honest rather than alarmist, because unrest and eruption are not the same thing, and the observatory has been direct about that distance. Their own bulletins state plainly that intrusions of new magma beneath a volcano do not always result in an eruption. The earthquakes and gas emissions at Kuprianoff could simply fade out with nothing ever reaching the surface. And there is a recent, well-documented example of exactly that happening at another Alaska volcano.